Can anyone hear me? Yeah. Okay. So I understand that there are people here who prefer me to present in English, so that's what I do. So my name is Eyal. I'm with the JFrog ecosystem team. In our team, we are developing applications, clients, and plugins for the DevOps community. And today I'm gonna talk a little bit about Jenkins and security. We're gonna talk about why security is important, how do we maintain a high level of security in our production environment, and I mean, basically, security in our ICD flow, and as a result, in our production environment. And let's dive right in. So let's start with the obvious. I mean, the goal of us as a DevOps community is to deliver software, to make sure that the process is smooth, is fast. We want to release fast. We want to help the organization achieve its goals, its business goals, and have software updates coming fast and easy to production, starting from the developer who develops the code, commits the code, and then we want to do testing, of course. We want to make sure that everything is tested, and then packaging, and then, of course, distribution to the deployment servers, or to the end users to consume the software. Okay. So we do have challenges, and that's life. I mean, it's good that that life challenges us, and the challenges that we are we are facing on a daily basis is more products. Okay. Many organizations, more and more products are being added. From a variety of users, of people. The DevOps team usually is not growing that much, but in many organizations, the development team grow. There are more and more developers added, more dev team, more products, more technologies. Okay. Various teams develop in different technologies, some of them in Java, and build their code with Maven or Gradle, other Microsoft technologies, NuGet, NPM, and more. And that means more package managers for us, and it means that our software is being deployed and being received and being expected to be deployed with various technologies of package managers. And of course, we get to a point where we have a merge or a complexity of multiple package managers working together. For example, a Debian that includes a TarGZ, that includes a WAR, that includes jars, and all of that is playing along together. All of this is coming to us, and we should make sure to streamline it and make sure that everything works no matter what they throw at us. We want to still make it work. And of course, more services, okay? So it's not just more products and more dev teams. We need to maintain more services in production. Sometimes the same application provides multiple services, and all of that has to be supported and maintained. And of course, we are expected to be able to deliver frequent releases, okay? We keep putting the bar higher and higher because we know that frequent releases result in more frequent updates, and we are able to compete better and provide better user experience and better response time for our users. And on top of that, we are expected to maintain a high level of security. Now, you guys tell me, how the hell do we do that? We don't even know what we are building. We are using so many technologies. We are not really familiar with the code. I mean, everything is coming to us packaged and in various technologies, and we are expected to make sure that our production is secure, or at least help the organization make sure that the production is secure, there are no security vulnerabilities, and our application is not at risk. Wow, how do we do this? Well, I mean, one obvious solution is testing, and more testing. Of course, we add more testing to our application. We test it. We try to think about various scenarios. The developers add tests. But you can test, you can test things that you know of. It's almost impossible to test against things that you're not aware of. Okay? I know what my application is supposed to do, but if it does something that I don't know about, or I didn't even think that it can do, how can I test against it? What happens if I use a dependency which, frankly, I don't even have a way to know that it's there. It's buried in some, Docker images somewhere, and it's vulnerable. And someone found out about it, but I don't even know that I have it. So, obviously, testing is crucial and important, but is not enough. So what do we do? Oh, by the way, the problem becomes even worse with containers, okay, with Docker images, okay? Because a container, it's like a machine that has a complete, hundreds and thousands of dependencies, of artifacts, and I'm supposed to get this container, understand whether it's safe, and just deploy it in production. By the way, that's one of the reasons why many organizations are not yet choosing to deploy containers to production, because we just don't know what's there. Imagine that, there is a Docker image that contains a Debian, that contains a TarGG, that contains a Word, that contains a jar, and whoa, the size of the tree is enormous, and except for, hoping that I'll put it in production and that everything will be okay, I don't have a lot to do. So I'm in trouble. Please help. So let's try this. We want to come up with a way to scan everything right after it is built. So we want Jenkins to tell us that the build that we created is perfect, is clean, or at least minimize the chances that I have any vulnerability there, okay? We want Jenkins to, in other words, block builds or block binaries which are vulnerable before they are promoted. And I don't even want to know about the existence of these binaries. I want everything to be automatic. That's a dream I used to have. Okay, so let's see, let's look at one way to do that, okay? So I want to have Jenkins build running, and I want this build to be scanned. I want this to be transparent to me, okay? I just want the build to be scanned. And I want, in some cases, for Jenkins to fail my build if it found something wrong with it. I want to have the freedom to choose, okay? I want to be able to say, hey, it's okay. I know about this vulnerability. I'm willing to live with it. But if I'm not sure, I just want to be built to fail. And I also want a report that tells me exactly the status of my build. And if there are issues, I want to hand them over to the people or to the person who should handle it so that he can fix it. And then, I could have a build that is clean and can continue its life cycle towards paradise, towards production. So let's start creating it together in Jenkins, okay? So I have here the first few lines of a pipeline script in Jenkins. And for those of you who are familiar with Artifactory and are using Jenkins with pipeline, those lines should be familiar to you. For those who don't, I'm here to walk through with you. It's pretty simple. So in the first line, we are retrieving an Artifactory server. Then we are creating a Maven build. We are setting the Maven build tool. I want to use Maven 339 in that example. Then I'm going to define the deployment repository, where I would like my artifacts to be deployed after the build. And I also want to tell the job where to take those dependencies from. Okay, so that's what I'm defining. And then at the last line, I'm doing rtmaven.run, actually telling Maven, go ahead, run the build, and deploy the artifacts, and give me back the build information. You see, dev build info? That's an object that contains the metadata about the build, the dependencies, the artifacts, and everything that is needed for me to continue working with this build. So the artifacts are deployed. They are somewhere. They are in a repository, which is the repository where artifacts should be before they are approved. They're like squared in a box there. Okay, let's continue. So now comes the fun part. Now I want to scan the build. So I'm creating a scan config. And in this specific case, it's very simple. I'm just providing it the build name and the build number, taking it from the build info object that I created. And once I have this scan config, I can go ahead and tell Artifactory, go ahead and have X-ray scan my build and give me the scan result. Okay? All right. So that's a simple example of what we can do. Now, let's look at the live demonstration. I have to tell you that I'm pretty scared about this demo because, you know, some of my components are installed on my laptop, some of them are on the cloud, so let's hope that the network holds up and everything works fine for us. Okay, so let me see if I can make the screen. Do you see the whole screen? Cool. Okay, so I have here two, I created, for the sake of this demonstration, two Maven jobs, two Jenkins jobs, a Maven one and a Docker one. So let's start with the Maven one. So right here, there's a pipeline script similar to what I showed you earlier. And here I have the scanning part commented out. I just want to run this build first without scanning, just to show you. Let's run the build. And it's running. And we have the artifacts, the build finished, and the artifacts actually starting to deploy to my repository. Let's give it a few more seconds. And that's it. Successful build. So far, no news. This is something that we already know. We see here the build information with all the build metadata in Artifactory with all my artifacts and dependencies inside the module. Okay, let's move on. Now I want to scan my build. We have some background music, nice. Okay, so let me uncomment this section. Now, look what I'm doing here. This is, are you able to see it clearly? Okay, cool. So I created a stage for scanning the build. This part you already know, build name, build number, scan config, X-ray scan, and scan config. And I'm getting the scan result. Now, look what I'm doing. I decided to print out the scan result by doing an echo. This is just to show you what result can be returned. The basic idea is, I mean, we don't always just want to fail the build. Sometimes we want to, create our own logic and read the data, read the summary, and then, according to that, take a decision as to what we want to do. Okay, maybe we don't want to fail the build. Maybe we do. Maybe we want to send an email, a Slack message, or do something else. So now let's run the build, have it scanned, and just print to the build log the result. All right, the build is running again. Tests, artifacts deployment again. And then 1, 2. All right, so look what we got. This time the build failed. Whoa. Why did it fail? Probably because of the X-ray scan, because it ran successfully for us a minute ago. So let's go and see. Okay, so here, as you can see, it tells us that X-ray scanned this build and found and actually threw one alert, okay? So we have an alert. Something is vulnerable inside our build, and we also get here a link to a report that we can see. And also, and this is, all of this is a JSON result of the scan result. So this is not really something for a human to read, but this is something that we can take and just have a code or a different piece of code read it, and we can develop our own logic. But as you can see, it includes everything, all the data, the issues, and everything that's found. So let's go and see something which is more for us humans. Just go to this link. Then takes me right to X-ray. And then I get to the alerts section in X-ray. Now, this is not an X-ray session, so I'm not going to go over what we see here. I'm just going to show you that by clicking on this, we see the detail about this alert. Now, look what it tells us here. We have a possible XML injection, okay? And there's a description here, and we have the information, we have the component, and now we know that this should be fixed somehow. Okay? All right, enough with Maven. Let's do something more interesting. Not that Maven is not interesting, but let's talk about creating a container build. So let's build a Docker image. So I created this Docker image, this job to build my Docker image. And I have here, again, some pipeline code. And let me just jump. Here it's publishing the build info of my Docker, and here is the scan config. And this time, I implicitly want to tell this build not to fail in case it finds vulnerabilities. So I just added this fail build false, but the same idea again. Now, as I said, when we're deploying images to production, the need for a scan for the whole Docker image is crucial. I mean, I want to have the whole image scanned for me, and X-ray can do that. It can actually go inside and understand what's in it, and analyze everything, drill down into the archives, and just understand what it sees there. So let's run the build. I see that my prayers are coming true. So far, everything works. Okay, thank you. 10 minutes alert. Okay, so let's see. If this build takes too long, we'll just talk about something else and then go back to it. But no, here, successful build. Again, the whole summary again. As you can see here, it's a lot longer. I mean, it's the whole Docker image. And I try to build here something which is, pretty small, just a few examples and a few layers. If I go to the summary again, I have the link again. So let's go to the link. And again, this is my build. This is the alert. Oh, I have here, I can see the actual issue. I mean, it actually found a public issue with a component, and it even gave me, let's see what this is. It's a link. It's probably a link right to the bug. So all of this is achieved by the fact that we are, notice, we are not dealing with artifacts here. We are not aware of the artifacts and of the dependencies of what we're actually asked to deploy in production. But we do know the build, and we want to act as, on the build as a higher level of abstraction, and this is what we did. We don't know what's in it, but we just know that there is a build, and we let X-Ray take care of it. And like any other build info that we're creating, we will see in Artifactory all the build information, including the specific Docker layers that are the artifacts and all the base layers which are dependencies. Okay, there's one more small thing that I want to show you, but before that, I'd be happy to answer any questions if you guys have. If not, then I go on to the next one. So, yeah, you're going to get a microphone.
Which version of X-Ray you implemented that?
This is actually version 173. 180 has been released, I think, yesterday. Any other questions? I can't see you because I have the light in my eyes, so. No one else? Okay. So the last thing I want to talk about is something that comes hand in hand with security and specifically with scanning, and this is promotion. Because we are dealing with builds, having a way to do things on a scan build, specifically when we're talking about Docker, is very, very important. And let me explain why, okay? So you have a Docker file, okay? And you're using it to build your artifact. And you built it, and you have the Docker image. Now, if you build the image again with the same Docker file, will you get the same image? Anyone? No. Why not? Exactly. Some layers are tagged as latest. I don't really know what I'm building. But there's one thing I do know. I do know that I had a build that created an image, and I knew that I could scan it. So I scanned my image. So this image is fine. I don't want to build it again. I just want to use it. Now, the way to use it is to take this whole image and just let it flow along. Let it move towards its goal, its paradise, production. And that's what promotion lets me to do, okay? So promotion together with scanning, together with the build notion, gives us, as DevOps, a lot of power in our hands to know exactly what we're doing and to know that we're secured, okay? So there are two ways to do it. I'm just going to show you. It's very, very easy. So one way, one approach can be, okay, the build is scanned, the build is okay, just promote it. I don't want to know about it. Keep it flowing, promote it, and you can do that by simply adding, a promotion section to the Jenkins pipeline saying, okay, if the build didn't fail, then promote it. And then I know that I have another repository with builds that are okay. Or I can just, parse over, read the result, and then take a decision. And there's another option. Sometimes I don't want everything to be automatic. Sometimes I want some control over it. Sometimes I want to have the option, by a click of a button, to say, hey, I want to promote this. So just take a minute to look at this. So I created here a small function called add interactive promotion. And what it actually does, it creates a promotion config that defines where do I want to promote my build. Okay, that's my target repo. And I can add another optional properties like a comment and whether I want to copy or move the build, etc. But I want this to be manual. So I just configure this here to give me the option to do it manually. Now remember that in pipeline we can create multiple builds at the same script, okay? So we can actually add multiple interactive options for multiple builds, allowing me or someone else who's in charge to take the decision whether he wants to promote this build or not. So I ran this build already, right? And when I ran it, I had this piece of code here. So actually what happened is that, let's go back to the Docker, that next to my last build, I have this small promotion icon here. Now, I get to the promotion window allowing me to do it. Now, this is more or less the same old promotion window that we use for many years now, but now we can do it for pipeline, for Docker, and for multiple images. And if I added multiple interactive promotions, then I would have here a drop-down that allowed me to select exactly which build I want to promote, if I want to promote all of them, etc. So just wanted to add this information about promotion, because promotion and scanning can bring a lot of value together. And that's it for me. So thank you very much, guys. Okay.